Biology is a fascinating subject. Today we'd like to tell you about one discovery in a part of biology called genetics. Genetics is the study of heredity in organisms and specifically the study of genes, which are small segments of DNA structures called chromosomes, and those make up an organism's information system.
For our purposes, chromosomes can be separated into two types, autosomes and the sex chromosomes. In general, organisms have several autosomes and an X and Y sex chromosome.
New research has shown that many genes on Y chromosomes are starting to migrate away from Y chromosomes and onto either X chromosomes or one of many other autosomes, shortening Y chromosomes or removing them altogether. To help you understand this new discovery, we have a story to parallel the ideas delivered in a study conducted by research scientist Jennifer Hughes at MIT.
Welcome to the Gene Home. There are many inhabitants.
Hi, I'm Mr. Y, and this is my pet Gene. We are very close.
But one day, Gene went missing. Mr. Y searched high and low for Gene, but could not find him.
Gene got a call from his friend Ada saying she found Gene. Mr. Y spared no time getting to Gene. When Mr. Y arrived, Gene wanted to stay with Ada.
Gene told Mr. Y that he felt like he fit with Ada better. Mr. Y let Gene stay with Ada, knowing that he would be happier.
So, what was the science behind all that story? Mr. Y represents the Y chromosome, and his pet gene was the EIF2S3 gene studied in Miss Hughes' research paper. In a variety of organisms, this gene has left its place on the Y chromosome and appeared on either autosomes or X chromosomes, and in some cases, like humans, both.
In our story, Gene leaves Mr. Y only to be found with Ada, who represents an autosome. In humans, the EIF2S3 gene has actually been found in both the autosome and X chromosome. In the X chromosome lies a backup of the gene, and in the autosome, the gene codes for sperm production in males.
In the original research paper, one figure reveals how many organisms have had the EIF2S3 develop on a variety of different chromosomes, represented by letters X and A respectively. This phylogenetic tree shows how over time the EIF2S3 gene has evolved in many species to exist on either the X or autosomal chromosomes. Notice how very few species still have this gene on the Y chromosome.
One of the big conclusions from this paper and the end of our story is that genes might be better suited on different chromosomes than originally thought appropriate. In this case, the pet gene, our EIF2S3 gene, belongs more appropriately with Ada the autosome than Mr. Y the Y chromosome. And this is just for one example genome. In other organismal genomes, Gene might be just fine with Mr. Y. Biology is crazy, huh?
Created using Powtoon.